In this video, we're going to take a deeper look into the RV7000's remote programmer and the Reverb section, as well as how the front panel parameters of decay, high-frequency dampening, high EQ, and dry and wet affect this Reverb section's settings. We're using a drum loop from the factory sound bank that we've heard before. I'll turn the dry all the way on, and let's hear the dry drum loop. When you first open the RV7000, the remote programmer is not viewed. Click the triangle and it is. To ensure that you're on the Reverb section, you can either click the light next to Reverb or use this button to switch the edit modes. You have Reverb, EQ, and Gate, as we've seen in the last video. In the Reverb section, you have the upper left-hand corner knob for Algorithm. This is going to switch between the various varieties of Reverb. We'll start with the small space algorithm. You can see that the other 7 parameters available for adjustment are size, mod rate, room shape, low frequency dampening, wall irregularity, pre-delay, and modulation amount. These parameters change for the different algorithms, but let's look at the one for small space first. The small space algorithm is designed to emulate anything from a resonant body to a small room. And if we look at the range of the size parameter, we have 0.9 meters all the way up to 9.7 meters. So we could do quite a small space or a small room. I'm going to start somewhere in the middle, let's say around 5.2. Notice that I have the decay setting about halfway up, the high frequency dampening at its default, and the high EQ at just below 1/3 near its default. I'm going to turn the dry wet up to about halfway. And as I play the drum loop and adjust the size parameter, you'll notice the difference in the perception of the room. In understanding how to shape realistic reverbs, it's crucial to see how these parameters relate to one another. Let's see what happens when I adjust the decay knob after adjusting the size knob. We'll go to the largest small space available, 9.7 meters, and we'll turn the decay down. See how the tail of the reverb pulls itself in. It actually adjusts the size of the room and the way that you hear it. Let's adjust the decay knob on this very large, small space. If I turn to a very small room and turn very high decay, I can do the same thing to a small space. Generally, around halfway is going to be the most realistic setting in correspondence to your room size. It scales according to the setting of the decay. You can take this from natural effects, like we've heard around the halfway setting, all the way up to 127, where you'll get some very unnatural but perhaps creative effects. Another determining factor of what kind of sound this algorithm is going to produce is the room shape here just below mod rate. In the case of the small space, we have 4 different room shapes, and you can see as I adjust between the various room shapes, we see different responses from the reverb waveform here. I had it on room shape 2, so let's adjust and look through some of the room shapes and hear the difference in tone that we get from our reverb. When engineers and producers look for rooms that have desirable reverb qualities, one of the things that they look for is wall irregularity. If the room has parallel walls, then reflections bounce all over the place in not very harmonic or not very musical ways. If the walls are more irregular, then you tend to get a more musical reverb, and this can be demonstrated fairly easily using the wall irregularity parameter of the small space. First, I'll turn it all the way down. We've been hearing it all the way up, and you can hear the stark difference While it may be useful for some creative applications, in the realm of realistic reverbs, it's not really something that we would want and is not very musically pleasing. Let's turn it up to about halfway and hear the difference now. Much better. Turn it up to full and we get a much less springy reverb. When I say creative applications for things like wall irregularity, one of the things I'm referring to is possible Foley or film sound design, in which case you may want to emulate a space with completely regular and parallel walls, let's say a small bathroom or a closet or something like that. In the case of a reverb for a drum track in a song, you'll probably want to lean more towards the irregular side because that's what today's producers and engineers look for in reverb sounds, and that's kind of what our ears hear as a high-quality reverb sound. Another thing that can affect the way that we hear the reverb is controlled by the modulation amount and modulation rate. In a digitally controlled reverb, we have the advantage of being able to randomly modulate the frequency of our reverb. These two controls control the rate and amount of that modulation. The more modulated the reverb is across the frequency spectrum, the more regular it actually appears to our ears. And you'll see this in spades when I adjust the mod amount from 0 up to 100. First, I'm also going to increase the dry wet, as well as the decay, and lower some of the high frequency dampening a little bit. Now we'll sweep through the mod amounts. Notice that we have a mod rate of 10, which is relatively slow since we can go up to 127. Now I'll increase the mod rate. Let's look somewhere around 80, and we'll start again from 0. Let's try again, this time decreasing the size of the room. I'll put the mod rate down to about 40, and the mod amount down to 0. Now, when we have smaller rooms, we tend to get more resonant and tonal reverbs, and the mod amount really helps for smoothing out this resonance. Listen to the small room with no modulation. Very unnatural. Adding some mod amount should clear this up. If we use the mod amount to randomly modulate the frequency, then we get a reverb sound that's more akin to noise than it is to something tonal. There's another parameter here that shapes how the reverb interacts with our dry signal, and it's pre-delay. And as its name would suggest, this puts a delay between the time of the dry signal and the time that the reverb is initiated. And if you watch the waveform display, as I move the pre-delay in milliseconds, you can see that the reverb waveform actually shifts itself away from 0 seconds on the timeline. So let's hear the reverb with no pre-delay. And now we'll add in about 28 seconds of pre-delay, enough for it to be audible. Pre-delay is used to keep there from being mud between the dry signal and the reverb signal. On drums, you'll tend to not have any pre-delay, but on an instrument like acoustic guitar, where there's a sharp, clicky transient at the beginning of the sound when you play with a pick, the pre-delay might be useful to clean up the reverb a little bit. There's some controls that I purposely left for the end of this video: the low-frequency dampening, high-frequency dampening, and high EQ knobs, because they all operate in kind of the same way. Overall, after we've shaped our reverb with size, mod rate, room shape, irregularities, pre-delay, and decay, we can adjust the overall low-frequency dampening with this knob. Let's try some examples. This can be especially useful with drums because the kick drum will produce a more boomy and unnatural, weird-sounding reverb, so you can filter out some of the reverb from the kick drum. This is entirely separate of the EQ section here that we'll be covering later. It's its own low-frequency dampening knob just for the small space algorithm. In the same way, the high-frequency dampening knob is applied globally no matter what the algorithm is. Also separate from the EQ section, it simply rolls off the high frequencies. And let's hear an example of that. On the other hand, the high EQ knob is a high shelving EQ used to add some brilliance or shine back into the reverb. The high-frequency dampening and high EQ knobs in conjunction with each other can really shape a reverb. Notice that I've turned the high-frequency dampening on to a pretty heavy level, so we're rolling off a lot of the natural highs, and we'll use the high EQ to boost some predetermined high-frequency ranges. In my experience, you use the high-frequency dampening knob to tame some of the harshness that you can get with a digital reverb. You can also use this in a creative sense for creating muffled reverb effects. The high EQ tends to add more of a post-processing brilliance that's not particularly natural, but is not necessarily bad in natural reverbs. So now that we've looked in depth at the small space, and used it to learn a little bit more about some of the general principles of these reverb parameters, let's move along to the next algorithm in the next video, which will be the room algorithm. Thanks for watching.